All right, now again, we're going to this next part, example 3, and this is talking about coterminal angles. And again, you should have already written that down. Coterminal. I'm sorry, I spelled this word wrong right here. It's not conterminals, it's coterminal. Sorry, my fault. We already should have written that definition down and also have that little box that's there in the book for it. Now, with it, it says if the angle is a degree measure, that alpha, that A, is the degree measure of an angle, then all angles, measuring the A plus 360 degrees, where K is an integer, and we know what integers are, like 1, 2, 3, 4, 5, -1, -2, -3, -4, -5 integers, are coterminal with A. So with these, example 3 says identify all angles that are coterminal with each angle, and then, in other words, find every single angle that's coterminal with that angle, no matter where it is. And then find one positive angle and then one negative that are coterminal to that angle. So here, when we do this, we're going to still do what we said, that alpha plus 360 degrees. And if we're trying to find the one that works for every single one, that means we're not going to have a number for your K, because K is your integer, and therefore if we're going to find one for every single one, we need to have kind of like a formula is what we're looking for. So when we talk about identify all angles, we're talking about the formula. So we know A is our angle here, which is 45 degrees. So 45 plus 360 degrees identifies all angles. So these are all the angles. So that means if you put any number in for K, you will find an angle that's coterminal to 45 degrees. So it doesn't matter what number it is, as long as it's an integer. Not a decimal, but an integer. So here, the other part says, okay, now that we found all of them, then we need to find one positive angle and one negative angle that's coterminal with it. So it doesn't matter if you use +1, if you use -1, -2, whatever. So your numbers are going to be different than mine, because I'm going to choose random things. So I'm going to start off with using K equals 1. So here we do this part here. So if we were to multiply 360 by 1 and then add 45 to it, we should get an answer of 405. And so that's our positive angle. But then if we do a K of, let's say, -2, just to throw something in there so it's different, you can do -1 if you want, that's fine. Let me put that in for K. So that would give me a -675. And both of these are degrees, sorry. Make sure you put that degree symbol there. Okay, so not bad, not hard. So the same thing is going to work over here with the 225. We know again that this is your alpha, your angle. So if you're having trouble drawing that, it's like that little fish, like the Jesus fish type thing that you see on people's cars and stuff like that. So here we do 225 plus 360 degrees. That's for all angles. And then here, let's go ahead and let's try something different. Let's say K is 2, just to do it. So 225 plus 360, 2 times 2. And that would be 945 degrees. And then let's try it also with a -1. So 225 plus 360 times -1. And that would give me a -135. So again, not bad, not hard. We can do this. But that's all they ask for. They say give them the one that's all the angles. So all the angles, which means it's a formula. And then we have a positive and a negative. So if I give you that on a test or a quiz or anything of that sort, it should be easy. Okay, so now let's jump to the next example, which is example 4. And this one's very similar, but it's going to be a little bit different because we need to actually do something here to go back, take it back from 775 to between 0 and 360. Now, with this, you can do it a couple of ways. You can look at it. Well, first off, let's read the directions for example 4. And again, if you need to stop it so you can write the example down and then work it out, do that. But here, example 4 says, if each angle is in standard position, and we already talked about, you already had standard position earlier, so hopefully you remember that definition. Determine a coterminal angle that is between 0 and 360. And then we're going to state the quadrant in which that terminal side lies. Now, some people do it the easy way, and they say, okay, well, with this first one, since it's positive, we can kind of like subtract 360 from it until we get to a number that's between 0 and 360, and they figure out what where that is. That's fine. That's perfectly fine. You can do that. I think that's the way I originally did it before because it made more sense to me. So if I subtract this by 360, so, and I don't have it written down, so let's go do that really quickly. That's 415. And then we did it again. 415 minus 360. Minus 360. Oops. Minus 360. That's 55. And so here, if you do that part, you can recognize, okay, that 55 is actually in which quadrant? Right, quadrant 1, because it's between 0 and 90. So we already know that point, that's in quadrant 1. Easy. Now, the book does something a little bit different, and you can do it that way if that makes sense to you, but I think this is easier to do it this way. That's perfectly fine. You can always use the formula that a plus 360k and then work backwards from there to find out what the angle is. But yeah, you can do that. That's fine. The other one also here, instead of you actually subtracting 360, because for B we have negative 1,297 degrees. And instead of us actually trying to subtract 360, because if we do that, we know we're going to make this number bigger. If you subtract a negative from a negative, it makes a negative number like larger, or a larger negative number, which, yeah, you know what that means. So instead of us subtracting it, we're going to add 360 to it. So that way it makes it smaller, and you will know what the actual thing should be. So if we subtract 360, add 360 to it, sorry, that'd be a negative 937. And then we take 937 and we add, negative 937, like I have there. So add negative here. So negative 937, and we add 360 to that. That gives you a negative 577. It's backwards of that one right there, kind of, sort of. Right, and then here we do negative 577 plus 360 again. We get negative 212. Okay, and then we try negative 212 is still a negative number, so it's not between 0 and positive 360. So we have to do this again, one more time. And so if we do that and we add 360 one more time, we get a positive 143. All right, so a positive 143 is in what quadrant? Quadrant 2. There we go. So that's between 90 and 180. That's quadrant 2. So hopefully you guys remember those numbers there, because we wrote them down a few seconds earlier and kind of flew through it, but you already know that makes sense. So I'm going to have you write this part down because I just want to see that you understand what just happened here. So for the first one here, for this part, we subtracted 360. which means that we took it and we went backwards around. So this one rotated how many times around? Rotated 2 times. And just like if we go back to what we talked about on example 2, that's 2 rotations. Sorry, rotations, not ratations. Ratations. Rotations. And then this one, would that be counterclockwise or clockwise? It would be counterclockwise. Why? Because it would be going, sorry, not counterclockwise, it'd be clockwise. Because it's going negative. And then the other side here, we're going around in a circle, regular circle, 360. So this is going let me make sure I did that. Did I do that right? Did I say that right the first time? Yes. No, sorry, this should be counter, because we're going backwards. Oh no, it should be counter because we're going backwards here. Wait a minute. Let me think. So we're multiplying it, well, we're subtracting 360. So yeah, it should be clockwise. Sorry, it's because it's going, we're doing negative. So this is clockwise. Because remember, negative is clockwise, counterclockwise is positive, and we're adding 360 here. And this went how many times? 1, 2, 3, 4 rotations. Counterclockwise. And again, remember, clockwise is negative, counterclockwise is positive. Clockwise negative, counterclockwise positive. All right, and that's the 2 examples there, and we have one more left.